All right, everyone's favorite for unit, logarithm and exponential function. So when we're working with exponential functions, the first thing you need to do is isolate your exponential. That is the number one priority. Once you isolate the exponential, you can either take the log or the ln of both sides of the equation. So here, to isolate our exponential, I'm going to add 7 to both sides. So I have 10 to the 5x plus 2 equals 59. And now we can take the log or the ln of both sides. On my key, I used ln, but now that I'm looking at this again, I'm going to take the log of both sides. So if you like to use ln instead, you could absolutely do that, as long as you're doing the same function, as long as you're doing the same operation on each side of your equation. It absolutely works. The thing here that is nice about using log base 10 is that the left side of our equation is in base 10. Log base 10 of 10 is 1. Anytime your base is the same as what you're taking the log of, you're going to end up with a 1. So we take the log of both sides so that we can pull down our exponent. And again, anytime we're taking the log and we have the same base as we do what we're taking the log of, so this would be 10 to some exponent equals 10. Well, 10 to the first power equals 10. So this whole thing is going to become 1. Just like ln of e, ln base e of e, e to the first power is e. This one's nice like that. So I'm going to change this whole thing, log base 10 of 10 to 1, and then roll from there. 5x plus 2 equals log of 59. And it is base 10, but we understand that. That's our normal base of log. I'm going to subtract 2. And remember, log of 59 is its own decimal, its own number. So you're not doing log of 57. It's log of 59 minus 2. So if you need to introduce some extra parentheses into your life here to keep yourself from making an error and making that log of 57, please do that. Whether it's parentheses around the whole term or parentheses just around your 59, make sure that you have that there. And then divide both sides by 5. Make sure you're dividing your log of 59 and your 2. So you can do a 1/5 out front. You can do it all divided by 5. Whatever works for you. Just make sure that you can match up an answer that you may see on multiple choice tests. All right, so that is equivalent to using the ln. You'd have ln of 59 divided by ln of 10 if you were using ln, and then the minus 2 and the 1/5 were all divided by 5. That is approximately, so if you put that in your calculator, you should get approximately negative 0.0458. So on the exam, you may be asked for the approximate value or the exact value. Be prepared to provide both. All right, 2 more logarithm problems. I'm going to bust through them all in one video. Next one, an expansion. So here we're going to use a couple different rules. First, in log world, and these rules work both directions. So log of x times y is the same as log of x plus log of y. Log of x over y is the same as log of x minus log of y. And log of x to the a is the same as a, log of x power rule. So product rule, quotient rule, power rule. These are the 3 that you need to be able to use. The first thing I'm going to do is to break this up with a quotient rule. So I'm going to do this divide by first. So I'm going to take this one here directly, put a minus in between. So ln of 3x squared minus ln of 7y. And you can absolutely do this in just one step if you're comfortable, but I like doing a couple. The next thing I'm going to do is break up the product rule. So I have a product here with 3x squared and a product here with 7y. And if you're expanding, multiplication becomes addition when you're going to write your logarithms twice. So ln of 3 plus ln of x squared minus ln of 7 plus ln of y. And the last thing I have here is the power rule. I have a power that I need to bring down. And that's the squared. And that is fully expanded. If you want to practice a condensed problem, you can go to the exit exam. Exit exam review. It has a couple good condensing problems. There are more expanding condensed problems under the exit exam, like more practice as well. Or with fresh eyes, you could come back, start here, and work backwards. You should get back to that guy if you are condensing. Just remember, when you're condensing to a single logarithm, not a logarithm divided by a logarithm. So this ln is written just once because everything is condensed correctly. Okay, one more logarithm problem. I really like this one. This is something that you'll see a lot in application problems. So here is our equation, y equals ae to the negative kt plus c, and we're solving the equation for k. I'm going to recopy that. And I'm going to, circle my, oops, not negative k, just k. So if we want that k all by itself, in order to get to it, we need to take the ln of both sides. And in order to do that, we've got to get this term right here all by itself. If we take the ln before we have that e term isolated, it's very likely that we're going to make a mistake. So my first two steps are going to be subtract c and divide by a. So just backwards order of operations. And the nice thing with a problem like this is you don't have any calculations to do. Nothing to put in your calculator. In a problem like this, you probably would have relatively big numbers if you had some numbers in here for your variables. So it's kind of nice to not have to deal with that. All right, now we have the e all by itself. And in order to pull down that exponent, we're going to take the ln of both sides. I'm going to pick ln because I know ln of e is 1. Now, when we go back and look at the options, if ln wasn't used, of possible answers up there, if ln wasn't used, we'll re-evaluate. Taking the ln of both sides allows us to pull that exponent down using the power rule. I think sometimes it's easier to see how to break up the problem if you put in those multiplication signs. Again, ln of e is 1, so that goes away. And now I need to get k all by itself, and I'm going to do that by dividing by negative t. Okay, so that's kind of a nasty answer. So let's go back to our multiple choice and see if we can match it. Okay, I can get it all in one screen. Okay, so I'm looking at A, and I see this plus t, and that does not match. So no thank you. Same thing with B, plus t log base 10, no and no. D, option D uses log base 10, and if we could use log base 10 in this problem, you would just have to deal with the log base 10 of E would not be 1, so you would have to divide it over at some point. So that cannot be right. Let's make sure we can match up all the pieces here. Y minus C over A, we're using ln. And here I divided by negative t. Dividing by negative t is the same as having a times negative 1 over t out front. So here, C is our answer. All right, I hope that one was helpful. And the next batch of problems looks like it's unit circle. I know unit circle and graphing trig functions. I know you will enjoy those.